Lesson 6.4. In this outcome, we will look at scatter plots. We will determine whether a scatter plot has a positive or a negative correlation, and we will also determine the equation of the line of best fit. Okay, so here's the first thing that I want you to do. Here's some data, okay, about Dalmatians' weight, their ages, and what their weight is in kilograms. I want you to take a minute, pause this, and sketch a graph of this information, okay? In your binders, you have plenty of grids that we haven't used. Just find one and use that, or just sketch it, okay? But here's the data, okay? So on my X column, I would have the ages, or on my X-axis, and on my Y-axis, I would have the weights. Okay, so go over 8 and up 6.5. Pause it now and take a minute to graph this out. Okay, now you've graphed it, and here's what it should look like when you're finished. Okay, it looks like this grid right here. We have our ages down here on our X-axis and our weight up here on the Y. Okay, your scale might not be the same, but it should look like pretty linear. Okay, this is a scatter plot because it's not perfectly linear, but we want to determine a correlation. Okay, and a correlation means what type of relationship are these two things having. Okay, and if we look at this, as our ages increase, so as we get older, what is happening to our weight? Okay, well, you should notice as we get older, our weight is getting bigger. Okay, we're getting larger, we're gaining more weight. Now, while most of us don't see gaining more weight as a positive thing, as a Dalmatian, we do, and these are going up and to the right. So would you say this has a positive correlation or a negative correlation? It has a positive correlation because it's going up and to the right. So I could just quickly sketch kind of a line of best fit here, and maybe it looks something like that, okay? And that means that if it's going up and to the right, that's a positive correlation, okay? So we want to look at the other types of correlation. So what type of correlations do these scatter plots have? So there's 4 of them. You can go 1, 2, 3, and 4, okay? And look at this. What type of correlation do these things have? Now there's no titles here. It's just plain old numbers. Are they going down and to the right or up and to the right? Yeah, these are going down and to the right. So they have a negative correlation, okay? Go ahead and pause it for a minute and see if you can identify the other 3. Positive correlation, where our data is moving up and to the right. As our X's get bigger, so do our Y's. Okay? Look here at this one, positive or negative? Positive. This is a positive correlation. Again, we could put one of these lines of best fit in here. Okay, let's try this right here. We want to get through most of that data. There we go. That has a positive correlation. As our X values increase, so do our Y's. Here we're at like 5, maybe 9. And then here we're at 10, 16. Okay? So as our X's are increasing, so is our Y's. Now look at this one. If I go this way from left to right, because that's how we read a book. Okay? As we go from left to right, what's happening to our data? Is it getting greater or smaller? It's getting smaller. Here I'm at 0 and my y-intercept is maybe at like 23, okay? When I move over to 20, I'm down to 4, okay? All right, or actually maybe like 3, something even lower. So as I move from left to right on the graph, my correlation is decreasing. So this one has a negative correlation, okay? Now this one is an example of something that has absolutely no correlation at all. As I move from left to right, I go down, then I go up, then I go down, then I go up, down, up. This thing has no idea what it's doing, okay? The data is all over the place. I can't draw one specific line of best fit anywhere, okay? It doesn't work, okay? So for this subset of data, there's absolutely no correlation. There's no relationship between what's happening on the x-axis and what's happening on the y-axis. Okay. Now, here's where you're going to have to look at these. So pause this for a minute and read the scenario to yourself. Okay. Compare each pair of graphs. Which line models the data better? Explain your reasoning. So here we have the same exact data. Okay. So we have the U.S. gallons per gallon per gallon, price per gallon. X-axis, both the same. Y-axis, both the same. And in fact, all the data points are the same. But which line of best fit better models the situation? It can be tricky, but it's A. A is the better option, and here's why. Okay? Look at that line of best fit. See how it best splits the data? On this side I have 1, 2, 3 data points. On this side I have 1, 2, 3 data points. And it hits 1, 2, 3 of them. Okay? So it's pretty well splitting the data in half. If you look at this line of best fit, I have 1, 2, 3, 4, 5, 6, 7 data points below the line of best fit, and I have absolutely none above. I do have 2 that touch the line of best fit. Okay? So that's what we're looking for. All this data right here is unaccounted for, okay? Whereas here, it's more evenly split. I've got about 2 or 3, oh, there's the other guy that's up there. And then I have 3 that's down here. So my data is more evenly split. And look at this, how most of my data is on the bottom half. So a good answer for this would be graph A is a better choice for the line of best fit. Graph A has the most points clustered closest to the line of best fit. Okay, so this is interpreting a line of best fit. You don't have to write it, you've already been given it. Okay, here's another one. Let me get this tool. Compare the graphs. Which line models the data better? So again, the same exact graphs. Which one is a better fit? Okay, go ahead and pause it. Write your answer, A or B and why. The answer is B. Okay? Because if you look here, there's 1, 2, 3, almost 5 that are directly on the line of best fit. Whereas this one has 1, 2, 3 that aren't even touching it. Okay? You have to take a good look at these because if you rush, as we do in most of our tests, which you're going to miss that. Look how similar these two graphs are. Okay? You have to take your time and look. This one has more data points on the line of best fit. Now, for gold prices, the year and gold prices, do these have a positive correlation or a negative correlation? Good, they have a positive correlation because as we go up in years, what also happens to the gold prices? It also goes up. So here's the answer for that. Okay, you can pause, take a minute and read that. Alright, final thing, now you got to calculate the line of best fit. So here was this data that was given to us. Counting change, number of shoppers, and then their total change back in dollars, okay? So, I've already graphed it for you and drawn the line of best fit. You have to write the equation for the line of best fit. And as I've been saying, you need 2 main equations. This is one of them right here, y equals mx plus b, okay? You cannot get anywhere without that one. So in order to get us started, which part should we find first, the M or the B? We should find the M, okay? Always start with your slope, okay? Let me get another tool. Now I'm going to help you, just in case you can't see it, to find 2 points that would really work for this. You got to find perfect intersections. I'm going to go with 18 and 11, okay? That's a good one to use. And then also 5 and 3. There's another point. Both of those lie on the line. They're on the line of best fit. Okay. 18, 11. And then we had 5, 3. Okay. Now, had they filled in all the numeric values, we would have seen that that's 3 and that this is 11. Okay. So those are the 2 points I want you to work with. Let me get a pen and write those out for you. Okay. So we had 5, 3. And 18, 11. All right, stack them. y2 minus y1 over x2 minus x1. Find your slope. Go ahead and pause it because I'm going to show the answer. Whoops, I showed the whole thing. I don't want to show you the whole thing. Let's see, let's do, whatever. Okay. The slope. Here's what I wanted to show you right here is the slope. This is the slope right here. Now that you know the slope, where can you plug that in? Plug it in for M. Now, try not to look for a minute. Pause it. Plug it in for M. Use one of your ordered pairs, plugging it in for X and Y. The answer below uses 5 and 3, so go ahead and use this one so you can check it with the computer. X is 5, Y is 3. Plug it in. Solve for B. Find where your y-intercept is. It looks like it's at 0, but we can't always go on looks. Okay? And you should find that B is actually, it's not 0. The y-intercept for this is negative 0.1. And then you write your whole equation. And that is the equation for this line of best fit. That best fits these shoppers and their total change, the relationship that these two have. Okay? I would pause this and do it again if you were not for sure on that. Okay? Because at this point, you've got to be able to write the equation for the line of best fit. Oh, they were the ordered pairs that I had. Okay?
Why are you pretending like you're